Welcome to the class of surveying. In this lesson, we will learn what is the meaning of surveying and why it is important for civil engineer. And after that, we will discuss about different division and subdivision of survey and the principle of surveying. Okay. So at the very first, what is surveying? Survey is simply the measurement of Earth's surface. Okay, and in the Earth's surface you can measure the horizontal distance or vertical distance, or you can simply measure the direction. Let's say this is point A, this is point B, okay, and they are at same elevation. In that case, by surveying you can measure their horizontal distance, that is L1. Or let's say here this is point A and at this point B, okay. So to measure the vertical distance from A to B you can use survey. And also, what is measure of direction? Direction measurement means, let's say this is line AB and this is line BC. So measurement of direction of line BC with respect to AB is defined by this angle theta. So this is also part of your surveying. Now it is clear to you what is the survey and why it is important. Well, you know, let's consider your country. Okay, let's say this is country A, this is country B. Simply to segregate their boundaries you need the survey. Okay, also to fix up the state boundaries in between a national boundary you need to use survey. Okay, next point is why do you need to use survey? Let's say you have some river. Okay, this is river Z. Okay, now you are supposed to make it navigable. Of course, to make it navigable you need certain depth. So to measure this depth also you need to use your surveying. Now as a civil engineer, why you need to study surveying? Well, now it is clear to you that surveying means all related to measurement. So for civil engineer, due to any construction of any project, survey is the basic. Okay, let's say this is the site. Okay, here you need to create a building, here a factory shed, here a chimney, here. Okay, and now you have to maintain a particular distance from this residential building to the chimney or to the factory to the chimney. How can you make sure that the distance are maintained inside? Of course, for that you have to measure this distance, and whenever you are measuring something, whether it is horizontal distance or vertical distance or direction, you are doing the surveying process. So for civil engineer, the main purpose of surveying is to prepare your, first one is map and second one is your plan. Okay, now what is the basic difference between a map and plan? Well, you may heard of a plan of building. That means, let's say this is the bedroom, this is your toilet, this is the dining. Okay, so this is the plan, and you may heard of a map of a country. Okay, let's say this is the map of country A. Now from this it is clear to you that a plan represent a large scale representation. So plan always represent large scale representation, whereas a map represent in small scale. Okay, now what is the meaning of this large scale and small scale? Well, scale means, I will discuss the scale in detail. Just for right now, for your understanding, scale means you have 1 kilometer distance, but in your page you cannot draw this 1 kilometer distance. You have hardly 297 mm. So what you do, you represent this 1 kilometer by, let's say, 10 mm. So here the scale is 1 kilometer in 10 mm. This is known as your scale. Of course, in this drawing of map of a country, it may be 50 kilometer or 500 kilometer, which is represented by only few centimeter, let's say 5 centimeter. Whereas in this plan of building, the size of your bedroom is hardly, let's say, 5 meter, and you represent it with 5 centimeter. So of course here scale is large compared to this one. Now what are the different type of your survey? Okay, so what is surveying? Surveying simply the measurement of earth surface. Okay, so this is not actually earth look like. The earth is actually looks like this. It is not perfect circle or not perfect ellipse. The shape of earth is defined a term that is your spheroid. Okay, this is the shape of earth. Now what is spheroid? Mathematically, if you take an ellipse, let's say this is the ellipse, so you have a minor axis, this one, and a major axis. Now if you revolute about this minor axis, in that case you will get a shape where the equatorial, this is equatorial diameter is more compared to this one, polar diameter. This is polar diameter. Okay, now consider the earth. Let's say this is the earth surface. Okay, now consider point A and point B. The distance in between this point, let's say in curvilinear path, is, let's say this is your, suppose, 5000 kilometer. Okay, so if you measure this length, of course the tape or chain, whatever you use, it has to be curved. Okay, you cannot measure the straight line path in between A and B. Okay, and now let's say this is the zoomed portion from A to B, and A is somewhere here and B is somewhere here. Now take 2 point, this is point 1, this is point 2. Okay, and the distance in between this is only, let's say, 10 kilometer. So comparatively, compared to this distance, it is very less. And here if you measure this distance by your tape, the tape is more or less linear. Okay, it is not curved. So the basic difference of these two surveying or these two measurement is, in first case we have to consider the curvature of earth. Okay, and in the second case we can neglect the curvature of earth. Okay, so based on these two fundamental things, the basic division of surveying is geodetic surveying. First one is your geodetic surveying, and second one is your plane surveying. Okay, so what is the basic difference between geodetic surveying and plane surveying? Well, in geodetic surveying we take into consideration the curvature of earth. Okay, this is for normally large work. Okay, this is for large measurement or large work, and this type of measurement need high precision. Okay, this type of measurement, or in geodetic survey, you need high precision, and only that case you consider this curvature. Now what about this plane surveying? Well, in this plane surveying, we consider the Earth's surface as plane surface. That means we neglect the curvature. Okay, and this type of surveying is valid for your less work or less area. Normally, when the work area is less than 200 square kilometer, in that case we consider the plane surveying. And of course, for any civil engineering project, the total area of the land where the project is going to be executed normally much less than 200 square kilometer. That's why in civil engineering every surveying is considered as plane surveying. So as a civil engineer we will discuss everything on plane surveying. Okay, now plane surveying, when we are talking about plane surveying, it has also many more subdivision based on the work. Okay, let's say simply you are interested to measure the boundary of your private property. Okay, let's say this is hardly your 2000 square feet. Okay, so you are interested to measure the boundary. So this type of surveying is known as either land survey or property survey, or you can say this is boundary survey, or you can also say that this is cadastral survey. Okay, now come to second type. The second type of surveying is your topographic survey. Now what is this topographic survey? Suppose, let's say this is city, this is a city, this is city A. Okay, in this city there are lots of building. Let's say there are some lake, let's say there are some river passing through this city. Okay, and let's say there is a bridge. Okay, let's say there is a bridge. Now when you survey all of these things, the natural lake, the natural river, the natural vegetation, the natural, your, let's say there is a pond also, a park also. Okay, this is also a park, and the man-made bridge, man-made building, everything you consider and prepare this map of city A. This type of surveying is known as your topographic survey. Okay, so your topographic survey include both natural as well as man-made things. And not only that, for preparing this plan you need to measure the height of the high rise, or you need to measure the elevation of the flyover. Okay, so this type of surveying or topographic surveying consists both your horizontal measurement as well as elevation measurement. Okay, now come to the third type of survey. Okay, let's say you have a lake and you are interested to measure the depth of water at different interval. Okay, and to measure the depth at different interval you need to measure this length or depth. So this is also one type of surveying, and this type of surveying is known as your hydrographic surveying. Hydrographic, so from the name it is clear that it is related to the measurement of water or something. Okay, now again next type of is your, let's say you are interested to measure the, in earth there is some latitude, okay, and also some longitude, based on which we can identify any place. So to measure this latitude or longitude, okay, you need to measure this latitude and longitude by the method of your astronomical survey. This type of surveying is known as astronomical survey. Now come to, so based on others different activities, there are different type of surveying. Now come to our civil engineering survey, or simply your engineering survey. Okay, so for any engineering project, first step is, let's say you are supposed to build your home in any land. Okay, let's say this is the land, and beside this land there is a road. Okay, also in other side there is a river which is flowing. Okay, so the first step is you go to the place or to the spot, and you decide whether it is feasible or not to construct a home here. Okay, you decide that yes, there is river, so water is available from here, and there is road, so transportation is also not any issue. Okay, you can carry your material through this road and stack in your site for construction. So this type of feasibility and an overall assessment of this area is known as your reconnaissance, that is RCO, reconnaissance survey. This is the overall surveying of this plot for exploring the infrastructure and the feasibility of your project. Okay, now coming back from this area, you prepare a plan or map of this area and decide that within this land here will be my farmhouse. Okay, this is my farmhouse, this is my swimming pool. Okay, like this you prepare, this is the lawn or park, you prepare some plan. Okay, and before the execution of the project you prepare this plan, which is known as your preliminary survey. Preliminary survey. Okay, so now reconnaissance is completed, preliminary survey is also completed, and plan is prepared based on this preliminary survey. Now you go to your land with the labor, material and equipment, and you start your construction. Okay, so this is the stage of construction. What you do first, this is the land, let's say this is the road, and with respect to this road you mark some point. Then you decide this, from this point at a distance of 10 meter there will be my farmhouse. Okay, and to ensure this 10 meter distance, what you have to do, you have to measure this length actually in your field. Okay, so now you are going to detail surveying or location surveying during the execution of the project. So there are three type of engineering surveying. First one is your reconnaissance, second one is your preliminary, and last one is your detail or location survey. Now come to the last topic of today's lesson, that is principle of survey. This is very important, lots of questions are asked from this topic. So what is principle of survey? Well, don't worry, there are only two principles. First one is you have to measure everything from whole to part, or the first principle is working from whole to part. What is the meaning? What is the logic behind this? I will discuss everything. Okay. Second is your to measure or to locate or to fix any position or any location that must to be done with respect to two permanent objects whose positions are known. Okay, so always fix any point with respect to or with the aid of two permanent object whose location are known. Okay, now come to the first point. What is the meaning of working from whole to part? What is the meaning? Let's say you have to measure or plot a rectangular area. Okay, and let's say this is 1.50 fixed point, and this is the actual. All these four indicated in blue color are actual point, and the inner one is like this. Okay, these are fixed point. Okay, now you start surveying, let's say from here. So instead, let's say you have located this point perfectly, and this point, let's say you have located it here. Then this point you have located here, this point you have located here. Okay, again from this point you have located here. This is the point. With respect to this point you have located this here. This is you have plotted here, and this is you have plotted here. Again with respect to this one you have plotted this point here. This point, with respect to this you have plotted this one here, and with respect to this one you have plotted here. Similarly you have plotted this point here. So finally your rectangle or plot looks something like this. Okay, so what is the result? The result is constantly you have increased the error. Initially the errors was this much, then it has increased this much, and then this much. So constantly the error, let's say this is E1, this is E2, this is E3. So you have increased your magnitude of error constantly. Okay, so this is the result of working from part, this is the part of the area, to whole. Okay, now let's do the same thing from whole to part. Okay, let's say this is the rectangle now indicated in red color. Okay, and these are fixed point, these are the fixed point here. In inner side these are fixed point, and this is the fixed point. Now you have started with outer side or from whole. Let's say you have correctly located this point. Then with respect to this one you have located this point, let's say somewhere here. Okay, then this point here, this point here. Then with respect to this one it has been plotted something here. This is here, this is here, this is here. And then with respect to this one you have plotted this one here, this is here, let's say this is here, and this is here. So targeting the inner side and fixing the outer one, you have minimized this error. Okay, so the error has been minimized. Initially the error was much more. Let's say this plot belongs to someone else, but you have, by the mistakes, you have increased this person's plan or plot to other person's area, which is not at all desired. So the main intention to work from whole to part is you can minimize error, and you restrict the accumulation of error. So this is the first principle. Now second principle. What is this? Fix any point with respect to two permanent object. Okay, so here you have fixed up this point, okay, to start the work from whole to part. And the second principle is saying that you have to fix up this point with respect to two permanent object. Now how that is possible? Let's say you have two fixed point. First one is Z, okay, second one is Y, and you have to plot point X with the aid of these two fixed point. How it is possible? Well, first option is you can take measurement from these two object or 2 point. Let's say this is L1, that is known to you, and this is L2, that is known to you. Okay, now you have intersect at this point and you have find the location of X. Okay, this is first option. Both are length and length. Okay, now second option. What is your second option? Second option is you can take perpendicular distance. This is Z, this is Y. You take the straight line and take the perpendicular distance. So this is 90 degree and this is, let's say, L, and you look at X. So here one is angle which is 90 degree and one is length. The third option is, let's say this is your X. Okay, here it is the X point and Z is, let's say, here and Y is, let's say, here. Okay, and this distance is known to you, that is L1, but this distance is not known to you, but you know the angle theta. You can look at this X. So third option is angle which is not 90 degree and a length. And what is the fourth option? Well, let's say this is Y and this is Z. Okay, this is X. You don't know any of this distance, that's why they are shown in dotted line. Okay, but you know with respect to YZ what is the angle theta 1, so you can measure, and also with respect to YZ what is this angle theta 2, and based on these two angle you can locate X. So the fourth option is angle and angle. Okay, so this is all about the principle of surveying.